Answers to assignment questions. Question 116. A hot metal block is cooled by immersing into a tank of cold water. The temperature of the water increases by 8 degrees Celsius, and we may calculate the energy absorbed by the water in this way, mc delta T. Similarly, the energy released by the hot metal block can be expressed in this way, mc delta T again, where 2.5 is the mass of the metal block and 70 degrees is the temperature drop of the metal block. And in this way, you may find the specific heat capacity of the metal. Question 117. In the experiment of mixing, there is one very important precaution, that is, to mix them quickly, because it can reduce the heat loss to the surroundings. Question 118. We have half a kilogram of water at 80 degrees Celsius mixing with 0.2 kilogram of water at 20 degrees Celsius. We net the final temperature to be X, and then we may express the energy released by the hot water in this way, in which the temperature changes 80 minus X. Similarly, we may also express the energy absorbed by the cold water in this way, and the temperature changes X minus 20. And so we may find the final temperature 62.9 degrees Celsius. Question 119. Very similar to the last question, but we don't have hot water, we have hot copper mixing with cold water. If the final temperature is X, we may express the energy released by the hot copper to be mc delta T, where C is 400, which is the specific heat capacity of copper, and that absorbed by the cold water will be mc delta T again. Remember to use specific heat capacity of water 4200 here. So the final temperature is found to be 20.5 degrees Celsius. Question 120. This question is more challenging because there is a container which has a heat capacity of 300 Joule per degrees Celsius, which means when there's temperature change, the container also has a energy change. The container was at the same temperature as the hot water, 60 degrees Celsius. So when mixed with cold water, the hot container also releases energy. So the total energy released by the hot water and hot container will be expressed in this way, mc delta T plus C delta T, where C is the heat capacity of the container. The energy absorbed by the cold water remains to be mc delta T, and so you may find the final temperature 33.95 degrees Celsius. Question 121. There has been an assumption so far. We assume that there's no heat loss to the surroundings, so the energy released by all the hot objects equals the energy absorbed by the cold objects. Question 123. Is an aluminium block add to 2 kg of water with the specific heat capacity of aluminium given. To find the final temperature, you may use the same formula to assume there's no heat loss to the surroundings, so that energy released by the hot aluminium will be equal to the energy absorbed by the cold water. So what are the temperature changes then? For water, the temperature changes from 25 to 31.29 degrees Celsius. But for aluminium, its temperature changes from 90 to 31.29. You can see the aluminium has a larger temperature change. And why? Because water has a higher heat capacity. So what are the heat capacities of aluminium and water in this question? For aluminium, the heat capacity is 1 multiplied with 900. And then for water, the heat capacity is 2 multiplied with 4200. Question 124. A hot steel block is mixed with some cold water. The energy released by the steel block equals the energy absorbed by the cold water. And in this way, the mass of water is found.